Hello, in this video, we want to take a look at another example of finding the arc length of a curve. In this case, we have a function in terms of y, which is okay. It's still just going to be that same formula of the integral from our bounds in terms of y, c to d, square root of 1 plus our derivative of our function in terms of y squared. So we want to take this function, y to the fourth over 8 plus 1/4 y to the -2, and find its derivative, square its derivative, and then plug it into our formula. So the derivative of this function is 1/2 y cubed minus 1/2 y to the -3. Or 1/2 y cubed minus y to the -3. Squaring this, just like the last problem, 1/2 squared is 1/4. We have y cubed minus y to the -3 times y cubed minus y to the -3, which becomes 1/4 y to the 6th. Y cubed times y to the -3 is just a -1 for those exponents canceling each other. So we have two of those from the outside multiplication and the inside multiplication. So we have -2, and then plus y to the -6, or y 1 over y to the 6th. Giving this all the same denominator, we get y to the 12th minus 2y to the 6th plus 1 all over 4y to the 6th. So we are going to plug that into our integral. So we get the length is the integral from 1 to 2 of the square root of 1 plus y to the 12th minus 2y to the 6th plus 1 all over 4y to the 6th dy. Finding that like terms, we have 4y to the 6th, or the common denominator, plus y to the 12th minus 2y to the 6th plus 1 all over 4y to the 6th. And just like the last problem again, 4y to the 6th and -2y to the 6th simplify to be a positive 2y to the 6th. That makes our numerator a perfect square trinomial that factors into y to the 6th plus 1 squared. All over that denominator is 2y cubed squared. From 1 to 2. Getting rid of the squareds and the square roots that can cancel each other now, we have the integral from 1 to 2 of 1/2 y to the 6th plus 1 over y cubed dy, or 1/2 1 to 2 y cubed plus y to the -3rd dy. Antiderivative gives us 1/2 y to the 4th over 4 minus y square y to the -2 over 2. evaluated from 1 to 2. This is 1/2. Plug in our upper bound first, so 2 to the 4th over 4 minus 1 over 2 times 2 squared minus 1 to the 4th over 4 minus 1/2 equals 1/2 times 2 to the 4th over 4 is 16 over 4 or 4 minus 1 over 8 minus 1/4 minus 1/2 is a negative 1/4. So we get 1/2 times, giving these all the same denominator, 32/8 minus 1/8 plus 2/8 or 33/8 times 2, 33/16 is the length of our curve from x equals y to the 4th over 8 plus 1 over 4y squared from 1 to 2.